Hey guys, welcome. I just want to let you know that I'm in the bottom right corner. You can see me. I'm pointing up at the notes, so it's pretty cool that I'm down here. I got my nice little Aloha Friday on, so I'm making this right after school. So let's get to it. Measures of central tendency. So we're talking about how we can measure the center of a data set. So we have a data set, full thing of data, and we want to measure using the center. We have two things to do that. We have a mean and a median. Okay, so the mean right here is what we usually call the average. Ooh. And I love one-word definitions. Mean means average. We're going to go ahead and calculate that today. And then median, we did this in class, but median just usually means the middle. So if we can kind of take these two terms and put them into one word, it would be average and middle. Okay, so let's take a look at two examples. We have this data set and we want to find the average. We can do that. The best thing we could do is to use a calculator. So if you have a calculator, please bring your calculator to class because this is going to be really helpful for us. Okay, so I'm going to add up all these numbers. Alright, you're going to have to take my word for it because I'm doing the calculating off the screen, but I'm going to do 8 plus 4 plus 7 plus 15 plus 8 plus 9 plus 14. Okay, I add all those up together, and you can see my calculator. I got all of them adding up, and I get 65. Okay, so I'm going to add them all up, and so basically, I'll even write it out. Why not? Whatever I write, you have to write. Whatever I write, you have to write. Oh yeah. Okay, so we get 65. Alright, the average is basically adding up how many I have, and then I'm going to divide it by the number of things that I have. I have 1, 2, 3, 4, 5, 6, 7 digits. So I'm going to divide it by 7. So in my calculator, I divide it by 7, and I get 9.28. Okay, so this is my mean. 9.28. Again, we want to go ahead and say the average is the sum of all numbers divided by the amount of numbers. Okay, so I sum them all up and I divide by how many I actually have. Make sense? I think so. So anyways, like I was saying, we have our average and we sum all the numbers and then divide by the amount of numbers that we have. Now for the median, we got to find the middle. But to do that, we got to order our numbers in the correct order. Right now, 8, 4, 7, 7, 15, 8, 9, 14 are not in the correct order. So let's go ahead and put those in the correct order. I'm going to go ahead and do the work for the median down here so I have some space. Alright, the smallest number appears to be 4. And then we have, let's see, 7. And we'll cross them out as I use them. And then we have 8. 8 again. 9. 14 and 15. Okay, not that many numbers, so I didn't really have to cross them out. Just double check. Looks good. Now we just count inwards. Okay, so I actually saw a student do this on the paper. He did like this. Okay, those two go to those two, those go to those two, those go to those. So what's in the middle? 8. So there's my median. Okay, so we have to have them in order and find the middle. Okay, so the one thing we must say about this, it needs to be in order. Okay. All right, let's look at this one right here. Now this one's already in order. So let's go ahead and count in. I have 10 problems. So we're going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the median is going to be somewhere right in here. So for a median, we'll put it down here. Median is going to be between 5 and 6. If you don't know, it's 5.5. You could always do 5 over 6 divided by 2, which is going to be 11 divided by 2, which is 5.5. Okay, now let's go ahead and find our mean. So we just got to add all these up. So this becomes a plus sign in between all these. Add them all up. Okay, you can do that in your calculator. I'm going to do it right now. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, and I get 55. So the sum is 55. divided by 10 numbers, and we get 5.5. Whoa! That was a mega sneeze. I think I'm okay. I have to sneeze one more time. Anyways, here we go. We get the mean to be 5.5 and the median's 5.5. Very rare occurrence that they're the same number. If we look at example 1, my mean is larger than my median. Okay? Let's talk about why that is. The mean is 9.28, my median's only 8. That's because these two numbers are really big. 14 and 15 are bigger numbers, so it pulls my mean upward. Down here, since we're equally spaced, they're 1 apart, my median and my mean are congruent. Okay? We'll talk about that more. Last thing I want to talk about is outliers. Okay? An outlier is a number that looks out of place with the rest of the numbers. An easy way to do this is to order them. So let's go ahead and order these first. Let's switch my color here. Let's go with this greenish color. Okay, so let's put them in order. We got 1, 1, I got 2 2s, 2 3s, and 4 4s. And then we got 25. Okay, I made this very simple to see, but I hope you guys can tell that 25 is an outlier. It is very large. If I were to put this in a histogram, okay, we got numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, jump across the page, 16, 17, 18, 19, 20, oh my gosh, 21, 22, 23, 24, and then 25. Okay, and then we did a little frequency chart. So how many we have? So we have 2 1s, so that's 1 and 2. We have 2 2s, 1 and 2. 2 3s, 1 and 2. And then 2 4s, 1 and 2. And then we have 25 way over here. Does that seem like it's an outlier? Yeah, the definition of an outlier. Let's go ahead and define that right up here. Okay, so if we define the outlier, now I'm reading from a piece of paper here. An outlier. Data sets can have members that are far away from the rest of the data. Okay? Numbers far away from the rest of the data, or data, however you prefer. Does 25 look like it's far away? Yes. Oh, it doesn't let me write across. Look at how far that is. That's a big gap. Okay, so this is a clear indication that we're talking about an outlier. Okay, so looking at that. Now this is very interesting that it creates for my mean and median. Alright, let's take a look at our median first. Median's in the middle. Count in 1, 2, 3, 4, 5, 6, 7, 8, 9 things. So number 5 is going to be in the middle of 9. 1, 2, 3, 4, 5. Median is 3. Okay, if they're equally spaced, my mean would also be 3. Well, let's find the mean. 1 plus 1 plus 2 plus 2 plus 3 plus 3 plus 4 plus 4 plus 25. Let's do this in our head. Do you think we can do it? I think we can. Well, kind of in our head. Alright, 1 plus 1, that's 2. That's 4. That's 6. That's 8. And that's just 25. 2 plus 4 is going to be... Let's just keep changing our colors around so we can do this. 2 plus 4 is going to be 6. 8 plus... 6 plus 8 is going to be 14, and then we got 25. Alright, 6 plus 14 is going to be, can't use that color, I already used it. 20 plus 25, so I get 55. Okay, so that's the sum. Then we got to count up all of our numbers. 1, 2, 3, oh, we already said it was 9, right? 55 divided by 9, might as well use a calculator at this point. Boom, 55 divided by 9, I get 6.1. My mean is 6.1. Why is it that high when there's only one value that's bigger than 4? Okay, one value bigger than 4, yet my mean is 6.1. So my mean is somewhere around here, and my median is over here. What is a better use of measuring the center? I'm going to go with the median is the better use of measuring our center. This guy is saying what is more accurate. What happens is the outlier has created my mean to be over-exaggerated. It doesn't really fit my picture very well. Okay, so my median of 3 better matches this data than saying 6.1, because most of my data is below 6.1 versus 3. Most of my data seems to be pretty close in there. Okay, all right, guys, that's all for me. We have a notes quiz, so be ready. Goodbye.